we're going to be doing multiplying fractions, which is actually really easy since fractions are essentially division problems, and multiplication and division kind of go hand in hand. It's actually easier than adding or subtracting fractions. So I'll just do an example here. 2/6 times 1/3. What you do is multiply the top and the bottom, the numerators and the denominator. So 2 times 1 is 2, and 6 times 3 is 18, and that's your answer. And since this number could be simplified by 2, 2 could go into both of these, so divided by 2, it becomes 1/9. 2 divided by 2 is 1, 18 divided by 2 is 9. So that's the answer, simplified. Division is just as easy, just a little bit harder than multiplication, just a different process. So if we have a division problem here, that I just did. Hold on, I'm gonna sneeze. What you do is you take the number that you're dividing by, and you flip-flop them. That's called the reciprocal. So in other words, we're gonna rewrite it. Sorry for the shaky camera. But we're multiplying it this time, and we're flip-flopping these around. Like so. So multiply this. This is 9. 3 times 3 is 9. 4 times 2 is 8. And that's your answer right there. As you can see, 9/8, the numerator is higher than the denominator. So let's see if I can remember how to do this. From the last lesson, 8 goes into 9 one time, leaving 1 left over. So we take that out. And it leaves 1 left over, and it goes into it 1 time. So it would actually be this right here. Finally, moving on to the new subject and off fractions. I took a test and 100%ed it. It's about 30 questions, and I feel pretty good about it. And now we're on area. So let's say this is 1 inch. 1 inch. To get the area. So that's height. And let's say width. And I know that's a little bit longer, but let's say that this is 1 inch as well. If you have the height and width, since area works on 2D, 2 dimensions, height and width, having a brain fart. You could now use the height and width to kind of even it out, where they converge here, like this. And this is the area in here, and you want to figure out what that is in terms of parameter. With this, since it's 1 inch on each side, 1 inch by 1 inch, and since these sides are also 1 inch by 1 inch, this is 1 square inch. Working with geometry, we want to figure out how much space is in this, and you use the mathematics based on the perimeter of the 2D object, the length and the width. And so its length times width equals the area. To the 1 inch area square. So it's 1 inch by 1 inch. So 1 times 1 equals 1. So this is 1 square inch. But there's also 1 inch on the width side, or length side, and 1 inch on the width side. So there's 2 inches for each direction the perimeter is going. So that means since there's 2 sides, it'd be inch squared. That just means for each side is 1. Since there's 2 sides, I don't know if that's making any sense. It's kind of difficult to describe. If it was just one line that was 1 inch, there'd be nothing to multiply by, so it'd just be 1 because there's one side. But there's two sides here. In order to get the area of this, it'll be a sum of 2. So 3 times 5 is 15 squared. The way of looking at this is 15 divided by 2 would be the size of the length and the width. So that's kind of what that symbol represents. So if you take 15 by squared, which is what we got here, which means if it's a square, it's equal sides. Even though this is 3 and 5, if we were to square it, like we did, find the area, it would count out to 7.5 on each side, because 15 divided by 2, 7.5. That means these would be 7.52 as well. Because when you have length and height, they could both converge and they'll be equal distance if it's a square. Take this shape, which clearly is not a square, and do the same formula. 3 times 1 is 3. So this is 3 squared. But this will always convert it into a square. We could learn how to do triangles, 3-point areas. And there's a little formula that you could do to figure it out. Let's say you have a square, and I actually learned this on a video. That was really helpful. Say you have a square, and it's 6 inches, let's say, by, 3 inches. Keep it simple. So 6 times 3 is 12 inches squared, like so. Let's say that if we cut it in half diagonally, like this, what would it be? That would logically mean, since it's equal on each side, that it would be 6 inches. Since it's cut in half, so it's 6 inches, 6 inches squared. And that's your triangle. And so the formula for a triangle is length times width divided by 2, or 1/2. So you take length and width and then divide it in half, and that creates your triangle. Or at least the area of a triangle. To go further into the triangles in geometry, there's a different formula as well. Instead of using length and width, like for the squares, for triangles you use base and height. For a triangle, you could use any side of a triangle as the base. What it does is that basically makes it saying that this is like ground level. So if you were to turn the triangle upwards to where it's flat, it's the base. Once you establish the base, you want to find the highest point of the triangle, which is right here, and draw a straight line down, just to give you an idea. And that's how you figure out your height of the triangle, the highest point, or the highest vertex. So, sometimes the line is inside of the triangle, which makes an acute triangle. An obtuse triangle is when the line is outside, once you draw a straight line from the highest point. The formula is base times height divided by 2, or 1/2, equals the area of a triangle. Say that we have this triangle here, and the base, represented by B, is 6 inches. Or I shouldn't have put the square there. It's just 6 inches. And the height is 7 inches. Now, if this was 2D, right, and say you were a carpenter, and or a concrete, someone laying concrete, and they had this triangle that was 6 inches and 7 inches at the height, and they said, I want you to fill this whole thing up with concrete. How much concrete would you need to fill up this area, right? we're talking about volume now, but in a 2D sense, that's kind of what I want you to kind of get a picture of in your head, is that you're essentially filling this up and knowing how much 2D space you need to fill this up, and it could work with any shape. And like I said, we're going to use it, the formula of this, base times height, and divide it by 2, and that will be your area. Base is 6, height is 7, so 6 times 7 equals 42, and then divided by 2, or 1/2, it's the same thing, gives you 21. Oops, sorry, gives you 21, like so. So therefore, this triangle can fit 21 square inches. So now we're moving on to circles and figuring out the area of a circle, which is a little more complex, I think. And you do that through pi, which is a value. And with a circle, really what defines a circle as being a circle. So if you take the center of a circle and go from here and measure from here to here, it'll be the same exact distance as measuring it from here to here or anywhere on the circle. It's the same distance, 360 degree around, and that'll make a circle. So the center of the circle is quite literally called the center. And then from the center to the point in which the circle begins, the line where it meets the perimeter of the circle, is called the radius. So the distance between the center to the perimeter is the radius. And it could be, and it has to be, if it's a circle, be the same distance no matter which direction it goes. In other words, if this radius from here to here is 1 foot, if this was a true circle, if it was 1 foot from here to here, it'd also be 1 foot from here to here, and from here to here. You get the idea. Now the diameter of the circle is the entire length of the circle, or width, depending on how you look at it. So it's literally 2 radiuses, because the radius is just goes from the center to the perimeter, and the brain fart. The diameter is the entire length of the circle. So the entire length of the parameter of the circle is called the circumference. What is pi? Pi has its own symbol, which is pretty accurate to what it looks like, but that's the pi symbol. And what it is it is a ratio from the circumference to the diameter. You remember the, the diameter is the length inside of the circle, and the circumference is the perimeter of the whole circle. To try to explain this, so this is the diameter, right? Or the radius. And it's from the perimeter to the center. And you're trying to figure out the length of the circumference. And this is how they figured out what pi is. And so if you were to take the length of the radius and was to kind of bend it hypothetically to fit the circumference, it would be about a little under, just slightly under 1/4 of a circle. 1/4 of the circle circumference. And so by the time you get to the third circumference, the third radius, I should say, doing that 3 times, it has just a little bit left over in order to make the full circle. It ends up being 0.14. So it ends up being in a total 3 radiuses plus 0.14. So pi is equivalent to 3.14. In order to figure out the the area of a circle. This is the formula. It's pi times the radius squared. Have you ever have anything squared, like 3 squared? That doesn't mean 3 times 2. It means 3 times 3. So it's 3 times itself twice. So if it was like 6 squared, it'd be 6 times 6. Or if it was, you get the idea. If it was 6 cubed, which is a 3, it'd be 6 times 6 times 6, which is a pretty big number. But that's how that works. Here we have the circle where the radius is 4. It could be 4 inches, 4 feet, whatever you want it to be. And so we'll write down the equation. So pi, which is 3.14, times the radius, which is 4 squared. So did the math, had to use a calculator because we're using decimals. So we have 4. So I took pi 3.14 times 4 squared. So the 4 squared is 4 times 4 is 16. Then multiplied 16 to pi. 16 times 3.14 is 50. So the area of this circle is 50 squared. Now we're going to be working on volume, which is similar to area. So with area, we worked with 2-dimensional shapes, like a square, a circle, triangle. However, with volume, you're measuring the amount of space in a 3-dimensional object, like this cube here, or a cone. Think of it as if you were to have this cube, like it was like glass, and you were to fill it up with water. How much water would fill up this entire cube? That's volume, is how much space this cube takes up. And since we're working in 3 dimensions, height, width, and depth, though instead of it being cubed, the number being cubed, like this square or rectangle, if it's 1, there's width and height. So there's 2 variables here, 2 and 3. Just for example, they'll be adding a 3rd dimension, length, depth, and height. So this would be 2 times 3, and it's 5 squared, because it's only 2 dimensions, so it's 2. But if it's a 3-dimensional object, there would be 3, since you're dealing with 3 dimensions. This would be a different answer, I think. But it'll be cubed, that's what it's called, when you have there's 3 dimensions you're working with. So it's the formula for volume is area times length equals the volume. So the area is the 2-dimensional side, which is width and height. So it's 4 times 2, which is 8. So that's the area, 8 squared. The depth is 6. Now we just multiply 8 by the depth, and 8 times 6 is 48. So it'll be 48. Since it's in 3 dimensions, it's cubed, like so. For the triangle, we'll work in the 2 dimensions first, and the formula is 1/2 times the base times the height. So what we're going to do is, so we take 3 times 5, which is 15. And then, like before I said, divide that by half, which turns out to be 7.5. My apologies, I wrote depth instead, or height instead of depth. I meant depth. So we got the base, which is 8. Oh, I'm sorry, 7.5. I was looking at the square we did last time. Then multiply that by the depth. Depth is going back, right? If you extend it backwards, it's the depth. Let's just say that's 10 inches. So now you take 7.5 times the depth, which is 10, which turns out to be 75 cubed, since we're working in 3 dimensions, and that's the area of that triangle. Do a circle in 3 dimensions, which turns out to be a what was that? A cylinder. So here's the formula, same formula to figure out the area, because we're going to figure out the area first and then multiply it by the width. And since it's a circle, that's the formula for the circle. Pi times the radius squared equals the area, and that's what we got to figure out first. So it's the radius is 3 squared. 3 times 3 is 9. So we got this times pi, which is 3.14. Kind of use a calculator because I'm bad with decimals. And it turned out to be 28. So 28 squared. So 28 is the entire area of the circle. And now we just got to bring it all the way back to this point right here to make it volume in the 3rd dimension. So let's just say this is 10 inches, right? Let's take 28, multiply it by 10, which is 280 cubed. So that is the volume, inches. I'll just say these were inches cubed. Here's the formula for a sphere and a cone. Sphere is, to get the volume, sphere is 4/3 times pi, 3.14 times r cubed. And r being radius. And for a cone, you do 1/3 times the height times pi, 3.14 times radius cubed. Or I'm sorry, squared. All right, so we're going to be doing the volume of a circle, or I'm sorry, a sphere. So I kind of shaded to show that it's a sphere, not a circle. And here's the formula for it. But I kind of broke it down to more simpler. So the radius squared or cubed times pi, 3.14, times 4 divided by 3, which is this factor right here, equals your volume. This was a sphere in 3 dimensions, and you got a radius of 3 inches from the perimeter all the way to the center. You could do this formula. Do the radius. So the radius is 3 inches. It's cubed, so 3 times 3 is 9, and then 9 times 3 is 27. So we have 27 as our radius. And 27 times 4 is 108. So the 4 times 4 is this. So we got the radius, multiplied that by pi, then multiplied that number, the answer we got, by 4, and now we divide it by 3. So 108 divided by 3 equals 36 cubed. So that is the volume of a 3-inch circle. The radius of 3 inches, I should say. Now we're doing a cone in volume, so you have radius and height to determine this. And here's the formula: 1/3 times the height times pi, 3.14, times the radius squared equals the area. So what you do is the radius is 3. 3 times 3 is 9. And then 9 times pi is 28.26. So I'll just put it right here. 28.26. Like so. So the radius was 9. And then multiplied by pi is 28.26. Did just now, this formula 28.26 is the radius or the area of the cone. But we need the volume, so we need to put in height, which is 8 inches. So what you do is 8, which is height, divided by 3, 1/3. I use a calculator. So since we got the radius, the sum of the radius and the area in 2 dimensions on the base, represented by this number, the area, we can now do 8 divided by 3, which is 2.66. So it's 2.66 height times 28.26. And so 2.66 times 28.26 ends up being 75.17 inches cubed. So that is the volume of this here cone.